This is a tutorial for the crazy 3x3x3 Mercury. Okay, now first you have to figure out which piece is different than the rest. So, in my case, this white side moves with the circle while every other side moves separately. When you find that, you want to take the color opposite of this, in my case a yellow, and you want to solve for the yellow cross first. And to do that, you want to have all of the yellow inner edge pieces solved. Okay, so I'm just going to bring them up here. And the only way to move these pieces around would be to bring down to the white side, putting them directly underneath the place, and then swinging it up. So now I have this cross on the circle, and now I want all the pieces to look like this. And just because of the way this moves, all of these inner edge pieces surrounding the yellow face will always be connected in the correct place. So they will always connect with their center pieces. Okay, so first find a outer yellow edge piece, like this one. And this one will go right here. And make sure that the yellow and this yellow are opposite of each other. And now I'm going to take this piece, the outer edge piece, and move it to any of the sides that move separately from the circle, like this red, as long as it's not the yellow. From here, I'm going to move it out of the way. Then I'll bring over the yellow piece, and then I'll pair these two up. Now I can just swing it up, and that piece is now solved. Same with this blue and yellow outer edge piece. I'm going to substitute it to pair with this inner edge yellow piece. When I move it up, that piece is solved. Same thing for this one. And first I have to take this one out. So I'm going to move this out to the green side and separate from this inner edge yellow piece. And now I'm going to put it back in. So the yellow is opposite of this yellow. Bring it to one of these sides. Then move it out of the way. Pair it up with this inner edge yellow piece. And match it. So now my first cross is done. Now I want to get my second layer of edge pieces. And for this, you want to first start with the inner edge pieces like before. So all I have to do is take these pieces, bring them up to the white side, and substitute them with the blue inner edge pieces that are up here. And again, substitute one of these pieces for this red. And the same for here. For this orange. Red again. And I have a green. And once you have all that, the white cross on the circle will automatically be solved as well. And also because of the way it moves, these pieces will always be in the correct order. So they always match. Now from here I want to get in the outer edge pieces for the second layer. So first find the outer edge piece. I have blue and red here. That will go down here. So it's going down to the left. So I'm going to start with that piece on the right. And I'll do R inverted, F, R, F inverted. Now, another piece, red and green, move the same way. So it's going to start on the right, and R inverted, F, R, F inverted. And then this piece, this orange and green outer edge piece, moves to the right. So I'm going to have this piece starting on the left, and I'll do L, F inverted, L inverted, F. And the last piece, again, moves to the right, so it's going to start on the left, L, F inverted, L inverted, F. Okay, so now I have this scenario where there's two outer edge pieces that have to be flipped. Using the regular algorithm for the 3x3x3 to flip these edge pieces will result in something that you don't want. So first, if I do that algorithm for the regular 3x3, you can see that these inner edge pieces get moved. So So I have to flip these around while avoiding that. The first thing I have to do is to get this piece and this piece adjacent to each other. So I'll just do R, U, R inverted, U, R, 2U, R inverted. That'll get them right next to each other. And from here, there's these two pieces, and then you're going to use this piece, the piece that's in between them. And from here, you want to have one piece on the front, one piece on the right. You'll do F, R inverted, F inverted, R, U, R inverted, F, R, F inverted, U, R, U, R inverted, U, R, 2U, R inverted, F, R inverted, F inverted, R. And that will solve all of these edge pieces. Now I have to match all of these outer edge pieces with these inner edge pieces. And that one is pretty simple. Right here, this piece is already solved. I have 1, 2, and 3 that have to be switched. And these 3 outer edge pieces are going in a counterclockwise motion. So I'll start with one piece on the right, one piece on the back, one piece on the left. I'll do R, U, R inverted, U, R, 2U, R inverted. And that'll solve those. However, there's another problem that could occur. So I'll show you that one right now. Okay, so this is the other problem that could occur. You might have a scenario where there's only 2 of these pieces that have to be flipped. And in that case, the algorithm I just showed you will always move 3 of them, so there's no way that you can solve both of these with that. So, in case you have it like this, where they're adjacent to each other, this time you want to separate them so that there's one piece here, one piece opposite of it. So for this, I'm just going to rotate these 3 counterclockwise, then this one will match, and these 2 will be switched. So these 3, going counterclockwise, so R, U, R inverted, U, R, 2U, R inverted. So from here, you can see that I have 1 and 2 pieces that are not solved. And this is only if the outer edge piece doesn't match with this inner edge piece, not the one on the white side. So from here, I want to have them at the left and the right. Once I have that, the algorithm will be F, L, R inverted, 2F, L inverted, R, U, R inverted, F, R, F, R inverted, 2F, R, F, U inverted, F, U, F, U inverted, F, U, 2F, U inverted. And that will solve that problem.